Okay, so it is recorded and live streaming on YouTube. You can just okay. Let's continue with this one now. So how we gonna study this example one? So we're gonna evaluate P and not P, yeah? Not P or not P. Yeah? So so the combination, because this is only one variable, so the variable is only P. So the combination is 2 to the power 1. Now, these two is for these two is for the input 0 and 1. So there are only two possible input. And this one, so that's the power, is the number of variables. And so that is here is only one variable. And so we have 2 to the power 1. So that is two combination. Yeah, again. So here you have P, so that is all the combination of P, so 0 and 1. And the next one is not P. Okay, so you have the not P. And so we saw before that not P will be containing all the opposite of P. So that is if P is 0 and not P is 1. And if P is 1, then not P is 0. Then the next one, yeah, so that is this one. This is for this. Yeah, that is for that. And this is for the whole sentence. Okay. Then that is the n. So again, the n is only 1 if they are both 1. So here we have all different. And so the value for this one is all 0. Yeah. So that's just to remind you that the n. So here, this Q is actually not P. So we have not P for the Q. And so here we have, the minimal value of P and not P. And because not 1 there, so they are all 0. The next one is evaluation of P and not Q. So here there are two variables. So we have 2 to the power 2. These two is for the two possible values, that is 0 and 1. And these two is for the is for the number of variable. Okay. And so this is how you're gonna do it systematically. Okay. First, you put 0, 0, and then 1, 1 for P. And for Q, you do alternating 0, 1, 0, 1. Okay. So again, for P, you have all 0 first, and then all 1s. And then for Q, you have 0, 1, 0, 1. Then we're gonna do the not P, not Q, this one. So that is that one. That is simply the opposite of Q. And so now the whole sentence, it is just that one P you take from here. And then this non-Q is you take from there. Okay. And that's going to be N. So you look at here and there. Then you see all the input of the input that all one. No, the input of all 0. And you look at all input that all 0. Yeah, and that's gonna be just 0. So that's the two inputs. And you look at the thing that all 0. Yeah, so that is here. Yeah, so that's 0, 0, and that's gonna be 0. All the rest will be 1. Okay. And all the rest gonna be 1s. Okay, so now the next example. So I guess I make mistake here, but we're gonna see. Yeah. So now we have 3 variables. So that is P, Q, and R. And so the combination will be 8 combination. That is 2 to the power 3. The 2 again is for the value 0 and 1. So that's all the possible values. And the 3, they are 3 variables. So here you have to systematically, you have to put it for P, all 0 and then all 1s, all 0 and then all 1s. So there are 4 0, 4 1s. And then for Q, you have alternating 2 0, 2 1s, 2 zeros, and 2 1s. And then for R, you have 0 1 0 1 0 1, and so on. Yeah. Okay. Then the next one, you're gonna process this. Yeah. Because we don't have this the same time, so we have to do it partly this one first, and then next the this and R. Okay. Okay, so P and Q. Again, you look at all the entry of all 1s, and that's going to be 1s. All the rest will be just 0. Yeah. And so you put all the rest 0. And then now, this is just, this is actually, yeah, so that is this one. This one is that one. Is actually this, and then NR. Yeah, so that is this and this. Okay, you see that? So we have to this and that. So we're gonna use the operation and. And because now luckily n is commutative, so you so P and R, P and Q is the same as Q and P. So that's a matter the order, the result will be the same because that's commutative. Okay, commutative. Yeah, maybe you know that from high school. So here again, you look at, because that's n, you look at all the input or 1s, and that's gonna be 1s. All the rest will be just 0. Okay. So here you have that two are 1. And so this gonna be 1, and all the rest is just 0. Okay. Then we're gonna do the P or Q. Yeah, so that is this P and Q again, because that is OR. Now we're gonna look at the input with both 0, and we put 0 there. All the rest gonna be 1. Okay. Now the implication. So we're gonna look at these two columns. That's the first one, and that's the second. And if the first one is smaller or equal than the second, then it's gonna be 1. If the first one is bigger than the second, then it's gonna be 0 or false. Now here, that's all smaller or equal. And so we have all 1s here. Okay, so the result is all 1. Yeah, so that's all 1s. Okay, for this, if the result are all 1s, then we call it tautology. So that's special name for that, tautology. And if it's all a 0, then we call it contradiction. Yeah, maybe you know that the word contradiction. Yeah, so that comes from this. It is contradiction. Now we have this one. Again, there are just two variables, P and Q. So there's just gonna be this combination. And again, for P, you have 0, 0, and then 1, 1. And then for Q, you have 0, 1, 0, 1. Okay. Now, because the bracket is there, so we have to process that first. So that is P or Q. And we have to look at which one is or both 0. And we put 0 there. All the rest is 1. All the rest are 1s. And so we have only the first row is 0 and the rest are 1. Now here we process the P and the second. Yeah, I'm gonna process this and this. Okay, so that is this one. And so we have, yeah, that is the end for that one. So again, we look at the 1s, and that's going to be 1. All the rest will be 0. And now the sentence itself, so that is the question. We have to compare the first row and the fourth row. If they are the same, then we put 1. If they are not the same, then we put 0. In this case, they are all the same. So we have 1s again, and that's going to be the tautology. Okay, so this is again a tautology. So for tautology, we have a special sign for that. So that is this symbol. Yeah. So maybe you know this symbol from high school. You use this symbol, yeah. So they are different than this one. This you have to evaluate if it is true or not. It is valid. But this one, we already proved that it is valid. Yeah. And if you have something like this, and it means it's valid, tautology, then you put that like that. Okay, so that's the difference. Yeah. Again, yang ini baru sentence kita harus buktikan apakah ini sentence ini nilainya bagaimana. Apakah nilai 0 semua atau 1 semua atau ada 0 ada 1. Ya. Sedangkan kalau yang begini itu nilainya 1 semua. Artinya itu valid. Ya. So that's valid proposition. Okay. So again, that's tautology. Yeah. Now, we call this a special name for this one. It's called absorption law. Jadi ini hukum absorpsi. It means that the P absorb the Q. Ya, jadi ini P and P or Q. Again, the bracket here. I look at the this one are different, yeah. And you have P here and P here, then the result will be P. So the P absorb the Q. Okay, so that's the absorption law. And there are two kinds of them. The other one, if you have this and that, you're gonna have the same, yeah, absorption. Okay, then this one is this. Now you have to read it like this. Okay. Then let's evaluate this. So again, there are two variables, and that's all the combination. And to make the combination systematic, again, you have to do 0, 0, and 1, 1s first. Yeah, 2 zeros and then 2 1s. And for Q, you do systematically alternating 0, 1. Yeah. If you do like that, then you're not gonna miss anything. Yeah. And that's gonna be very fast. Again, for this, we already saw this. Then the next one, we have to put the non-P, that is to accommodate this. Yeah. So this one, we already done it, that is the left side. And then now we're gonna have that one, and then after that, we're gonna evaluate that one. Yeah. Okay. Then, so non-P is just the opposite of P. Yeah. Non-P, that's the opposite of P. And then now non-P and or Q. So that is this one or that one. Now again, for N and or, they are commutative. It means that you can just interchange the order. So P and Q is the same as Q and P. And P or Q is the same as P, Q or P. Yeah, P or Q is the same as Q or P. Then you look at the, yeah, the same, that is just or, and that's the result. Now you compare them. Yeah, so that is, if they are both, the input are the same, then that's gonna be ones. Yeah, and you see that they are all ones. So this is another tautology. Yeah, and so I give them, so it is just I. Yeah, you won't find this in any literature. I just give them the name implore. So implore stand for implication to or. Yeah. So that is this implication. So that is implication. You translate that to or, but you put the not for the first variable. Okay. Again, you can just convert this implication to or, but don't forget to put the not for the first variable. Yeah, so that is that one. Okay, so that is the implication or. Means that from implication to or. Okay, so that's another tautology. And there are some. So this is another one. Okay, so here, so it is the same, yeah. So it is just implication, and then now you do the first one. So the first side of the implication here. So this implication, this one is that one, yeah. So this implication is that one and not that one. Okay. Now here is just that. Okay, and then when you, so it is just n of the first and the third row. So the n of this and that one. Okay. So again, you look at the ones, and that is you come out with this, and then you do okay. So here without the bracket, actually you have to read this as that bracket. Yeah, because this has higher priority and than that one. So the bracket is just like that. Now we have already here, and we have to imply that one. That is that one. So the implication is that way. Now n and or are commutative, so means that you can interchange the order. So p and or are commutative. So n and or. P and q is the same as q and p. P or q is the same as q or p. But p implies q. Yeah, if p then q is not the same as q implies p. Yeah, so that is p implies q and q implies p. So these are not the same. Yeah, not the same. Okay. We're gonna see. I still use this the same, but it's actually this one. Yeah. Okay. So when we do that, we see that this is all true. Yeah. Yeah, so that is all true. And so this is, yeah. Because this is tautology, it is again tautology, that's all one. So this implication, yeah, so this one, this implication, we have the same similar symbol for that with two stripes. Yeah, so that is this one. So the same arrow with two stripes. Okay, so before we have for this one, we have this. Yeah, but now for one arrow, we have arrow with two stripes, two lines. And it's called modisponens. Now, this is a very, very important. And you can associate this with the following. Yeah. Suppose that we say that if it is raining, then I'm not going to campus. If it is raining, then, so if, then I'm not going to campus. Then the fact is it is raining, so I can conclude that I'm not going to campus. Yeah, so that is modus ponens. Okay, now this one, so this is an easy one. So here, that's all zero, we call it contradiction. Okay, so here's some exercise, you have to do it, but I'm not going to collect them, but you can you have to do it nicely. Okay, then I give you some other exercise, then you have to collect. Okay, now so far any question? Okay, no questions so far. Yeah, you can just watch the movie, the video I gave you. So that's the same video. Okay, next. Yeah, you can see this. Yeah. Okay, so if S and T are proposition, and S, the conditional T is tautology, then we say that S and T are logically equivalent. And we use this symbol. So I already explained that before. Yeah. So if it is like this, when we evaluate now, S can be anything. Yeah. So M can be a P, and also S can be, yeah. S can be P and Q or R, yeah, and T can be anything, yeah, something like this. Yeah, so not only S, but it can be expression like that. Okay. And if when we evaluate them, then we see that they are actually logically equivalent, means that this one is tautology, then we use that symbol, and we saw that this can be done with a truth table, but and now, for example, this, yeah, you can evaluate that with truth tables. So this is the basic. Then there are two variables, so we have a combination of 4 combination of values, and that is something like this. Again, systematically 0, 0, 1, 1, and then 0, 1, 0, 1. Then we evaluate this first, and then that, and then this, and then that. Okay, this. Sorry. This, and then this, and then that. Yeah. Okay. And then this one. So that's how we evaluate that. Okay, so that's we're gonna do in the table. So P and Q, again, that's we're looking for the ones, and then that's the result. So you're gonna know this if you keep practicing, yeah. And then the non, of course, that's the opposite of that one. So 0, 0, 1, 0, 0, 0, 1. Now the opposite is, of course, 1, 1, 1, 0. And then we have the non-P and not Q. Non-P, non-Q. It depends. Some people prefer to do not P, not Q, but some people non-P, non-Q. Doesn't matter. For us, it doesn't matter. As long as you understand what it is. Yeah. So non-P is the opposite of P, and non-Q is the opposite of Q. And so just you get like that. Then the OR, that is, you do those column, and that is the OR of them. You look at the 0, all 0, that's you put 0. All the rest are ones. And then now the whole things, you compare the two column, that one and this one. So this one, this column is this, and that column is that. Okay, so this column is this, that column is that one. Now you compare them, compare the value. If they are the same, then you put 1 there, and if they are not the same, then you put 0. And in case they are all the same, so they are tautology. Okay, now we have, and because they are tautology, so we put this symbol there. Yeah, so it means that it is valid, logically valid, tautology. Yeah, and we say that this one is equivalent, logically equivalent to the right side. We put like that, and it is, we have a law for that. It's called De Morgan's law. Yeah, De Morgan's law. Now you have to memorize this like this. So it is in the bracket. Yeah, the note of that, you take away the bracket, but you put this one. Yeah, so they are the same, different. Yeah, so this is N, that is OR, and there's another Morgan law. If this is OR, then you put that N. All the rest are the same. Yeah, so that's the Morgan law. Okay, so that's, this one is the same as that one. And that is the same as this. Okay. Now, later we just gonna use these laws and we're gonna prove things. Okay. So we don't have to do that with the truth table, but we just gonna use this law and we use them to prove other variation. Okay, so this is how you memorize them. So false, that is false or 1. So we just make false or z, false, that's, we mix up sometimes false and 0, true and 1. So conjunction, that is the N, that is the minimum of those. Disjunction, that is the OR, that is the maximum of that. And double negation, if you say negation 2 times double, then that's the same as you just ignore them. Okay, the same as this one. Yeah, so you compare this minus minus, ya, minus minus 2 itu sama dengan 2. Ya. Minus 3 itu sama dengan 3. So this is idempotent, ya, bukan impotent. Idempotent. So this P and P, that's the same as P. And P or P, that's the same as P. When I say it's actually the same, it means that equivalent, logically equivalent. Yeah, logically equivalent. I said the same as, because when I say that's the same, is actually I say this, but what I mean is this one. Okay, so that is the same, and it is the logical equivalent. Okay, so don't be confused. Yeah. So for example, x equal to 1 plus 1, and that is x equal to 2. Yeah, you can just put like this. Yeah. Now this one is on that side, but the other side is not. This one is not right, because x is 2 doesn't mean that x is 1 plus 1. Yeah, x could be 1 and 2 minus 1. Okay. Okay, then next. Yeah, so this is, you can compare this with the x square. Yeah, x square equal to x. That is only for if x is 0 or x is 1. Okay. Okay. Ya. Jadi untuk n itu for n, that is whatever it is, that's you can just the number, whatever you put the number there, that's just gonna be the same. Okay. So 0 and 0, that is just 0. 1 and 1, that is just 1. Okay. So that is if the number is 0 or 1, then x squared equal to x. Then this is the domination. Domination means that the 0 with operation n that's gonna dominate anything. Dominate artinya akan dominasi, ya, akan berkuasa, ya, berkuasa terhadap apapun. Ya, so you have 0 and n, that's just gonna be anything. While 1 or anything, then you're gonna have also 1. So 1 or 1 and or, that's gonna dominate anything. Yeah, so this is the minimum and that's the maximum. So we know this already. Yeah. So because n is the minimum, so whatever it is you put there, then 0 is always the lowest. And is or the maximum, whatever you put there, then 1 is always the highest. Yeah, doesn't matter what the value is. If you put or 1, then it's just gonna be 1. Now, this is the identity. We already mentioned this before, the identity. Yeah, identity is, for example, for addition, the identity is apa? Untuk addition apa? What is the identity for addition? What? Identity for addition?
Plus.
Hah? Apapun tambah bilangan itu sama dengan apapun. Bilangan apa itu?
Zero.
Zero. And for multiplication?
1.
1. Yeah. So that's the identity number. Oke, jadi apapun kali 1 itu tetap apapun. 5 kali 1, 4. 5 kali 1, 5. 4 kali 1, 4. Ya, dan seterusnya ya, apapun. So here, so that's the identity for N, and this is the identity for OR. Okay. 1 is the identity for 0. No, 1 is the identity for N, and 0 is the identity for OR. Okay. Yeah, so that is that one. And this one is for plus. Yeah, 0 is the identity for addition. Okay, now inverse. Yeah, we already talked this before. Inverse, that is something that is when you operate that, then it's gonna give you the identity. So for example, what is the inverse for addition for 2 or for 5? What is the inverse for addition for 5? So it means what number when you plus 5, then it's gonna give you 0, the identity. Apa? Bilangan apa yang tambah 5 jadi identitas, identity? Identity for addition is 0. Jadi bilangan apa tambah 5 sama dengan 0?
Negatif 5.
Hah?
Minus 5.
Ya, minus 5 ya. So that's the identity for. And how about multiplication? What is the identity for multiplication again? 1, right? So for example, what is the inverse for 5? For multiplication, what is the inverse for 5?
5 power minus 1.
Yeah, so that is, so that is 1 over 5, yeah. So per 5. Okay. 5 power minus 1, that's good. Okay, so these are the inverse. So the inverse for this is that. So that's always like that, yeah. And yeah, so P or not P is always true, whatever it is. Yeah, for logic, yeah, because it's only two value. And P and not P is always false. Now the commutative, yeah, commutative. So P and Q, that is equivalent to Q and P or Q is equivalent to Q or P, and P if and only if Q is equivalent to Q if and only if P. So these are the things that you can just, so the order doesn't matter. So some people prefer to put for N as multiplication, yeah, and for OR is for addition, and for the B conditional is for the same sign. Okay. Now implication is not commutative. So P implied Q is not the same as Q implied P. And here is associative, you know this already. If you have the bracket like this, yeah. So pay attention that this notice that the operation here are the same, yeah. So that is N, 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 N. Yeah. Then you can just move the bracket like that. Yeah. The same for the OR. Okay, so that is for plus, and for multiplication also the same. Yeah. You can just move the bracket. So it doesn't matter which one you do first. And again, pay attention that we're talking about the same operation. Yeah. So that is the same operation. Okay. And then the distributive law. So it is maybe you know this for the arithmetics. Yeah. Now, so this is N, and that is OR. Now the N is distributed. Yeah, so the N is distributed there. So here become P and Q or P and R. Yeah, so that's P and Q or P and R. The same as when you interchange the operation. The same thing, yeah. Here you have OR, N, it is N OR. So you distribute this to there. So here you have OR here. So that is the OR. You have OR here and OR there, and the N is there. Okay. So you think of this distribution, yeah. So that is X times in the bracket Y plus Z equals to X times Y plus X times Z. But here you cannot interchange the plus and multiplication, ya. Jadi distribusi untuk aritmatik itu cuma perkalian terhadap penjumlahan, bukan penjumlahan terhadap perkalian, ya. Okay, but here conjunction to disjunction and disjunction to conjunction. So that's the distribution. Now absorption, we already saw something of them. So it is we listed here again. And again, so here there are different operation, and you have here the same variable outside and inside the bracket, then you can absorb the other variable. Okay, so here the P absorb the Q. Yeah. So that is the absorption law. Now, this is the Morgan we already showed before. And if you have something like this, then you can distribute. So this is ini sebenarnya distribusi ya, distribusi N, distribusi not ke N. Tapi kalau untuk distribusi itu N-nya itu tetap yang before untuk distribusi, tetapi yang untuk ini itu N berubah jadi OR. Ya, so you distribute the not to each of them, but the N become OR and the OR become N. See here? Yeah, so again here this one become OR and OR become N. And so the N is the not you distribute there and also there, but pay attention that the operation change. Yeah, the operation from N become OR and OR become N. So that's how you memorize those things. So these are very important, that very useful. Yeah. Then yeah, so here, then you show this. Here you distribute that, and then you change the operation. The same for that one. You distribute the not, and then you change the operation. Yeah. Now contraposition. So this is the contraposition. That is for implication. Now again, implication is not. Yeah. So this P Q and Q imply P. These are not the same, yeah, not equivalent. Yeah, so they are not equivalent. Not equivalent. Yeah. What is equivalent is when you do P imply Q, Q implies now what make it equivalent is this. You put the not here. Yeah, something like that. Then it is equivalent. Yeah. So that is the contrapositive. It's called contrapositive. Okay. Yeah, so again, implication is not the same with that one, but when you put the, again, so it is good for animation. So that's why animation is very important. So that's not important. So again, so it's not equivalent like this, but when you put the negation there to each of them, that is going to be equivalent. Okay, so that is the contraposition. Contrapositive. Now here's some terms that you may not. Yeah. If this is the proposition, if this is the proposition, then we call it S. Okay. Then the contrapositive is the same. the same as S. That is, when you put not Q, imply not P. But the inverse, we call it inverse, is just the same here, but not P and not Q. So usually you use these two to prove that P is equivalent with Q. Yeah. When you put P is equivalent with Q, then you prove that it is this one and that one. So that's the two things that you have to prove to usually to prove this one. Ya, biasanya untuk membuktikan bahwa ini P ekivalen dengan Q, maka yang dibuktikan adalah bahwa P implies Q dan Q implies P, which is the same as not P implies not Q. Ya. Okay. Now these one are the same. But the terminology is different. So here is the converse and that is the inverse. So this one is actually the contrapositive. This is the contrapositive of the converse. Yeah. Okay. And then yeah, so they are not the same as S, yeah. Now equivalence. Yeah, so that is what I mentioned before. If you have to prove this, to prove that they are equal or equivalence, then you have to prove the implication to one side and the implication to the other side. Yeah, so that is actually you do P. Now you have to prove this. Then you prove P imply Q and Q imply P. So this should be N. Yeah, so that is. So that is N. Yeah. Okay, then implore we already saw that how you're gonna convert the implication to not to or. That is implore is implication to or. That is the implication and that is the or. Then you have to put that sign, the not sign in front of the first one, not the second one, the first one. Jadi put the not sign to P, not to Q. Okay. Okay, so that's how you actually memorize those things. And next week we're gonna play with these things. Okay, we're gonna, so that's gonna, you're gonna have fun next week. We're gonna play with those things. Okay, now you can just do this exercise. And next thing we're gonna do that. Okay, any questions so far?
Sir,
If no-
can you give us more info about the exam?
exam or
Yes.
later the exam. You're gonna have so we're gonna meet like this, and I'm gonna give you some exercise, and each exercise will be time limited. Okay, so for example, I give you exercise problem number 1. Then you have to make it in 10 minutes. Then you have to do it in 10 minutes. After that, then you have to leave it. Then I'm gonna give you second exercise. Then after you do it, then you leave it. Then you combine them and submit to me. Submit to the link. Okay? I don't worry about that. If you study my if you follow this, yeah, if you miss this apa? Yeah, for those who do the Peximinas, we're gonna finish here. So you can just go to the exercise practice. Ya, jadi kalau nanti you miss this this lecture, you can just use so it is streaming live streaming on the YouTube. Then you can just check the YouTube, the Infimux. Then it's actually if you watch the video I give you, then you will be set up for the mid exam easily. Okay, because your friends are gonna do the Peximinas with them. Okay, support them, yeah, support and with them so that they're gonna be the champion for to get medal for the national competition. And next time you have to do it, okay? From now on you practice. Ya, jadi ada beberapa nomor yang memang susah sekali ada peserta. Nah, itu yang kalian ambil seperti dangdut, seriosa, keroncong. Itu dari unsrat itu sedikit sekali yang jaga ikut. Nah, nguni mesti sekarang juga latihan-latihan Jo. Kalau ini rasa nguni suka keroncong, ya. Bengawan Solo, ya. Latihan-latihan begitu ya. Kalau seriosa ya, so tahu lah seriosa bagaimana, dangdut bagaimana, dangdut itu yang penting dipegang ya begitu kan. Coba Jo latihan dan coba tampil next year. Kalau yang sekarang belum, next year tampil ya. Okay, see you next time and then good luck for your practicing Peximinas ya. Dangdut, keroncong, seriosa. Itu 3 yang susah sekali. Untuk orang itu kurang ada paksa-paksa tuh. Dangdut kurang ada paksa. Karena masuk juga dangdut. Kan? Baru seriosa itu kurang ada cari di mana Stockholm. Akhirnya dapat seriosa. Keroncong itu gayanya agak rock tetapi dipaksakan jadi keroncong. Oke, mudah-mudahan orang sukses dan we gonna see the result. Okay. Thank you very much. See you next week.